Okay, the title of this talk is Special Relativity, Moving Goalpost Example, Acceleration. The moving goalpost method allows special relativity to say one thing and then say the opposite. There are many examples of this, and here is one example. There's a claim by some people that special relativity does deal with acceleration, and there's a claim by other people that special relativity does not deal with acceleration. So special relativity is making both claims of special relativity does deal with acceleration, and special relativity does not deal with acceleration. So I've got from this website of a blog, a person who says special relativity does not deal with accelerated motion. And then when I go to Wikipedia, I find Wikipedia says special relativity, contrary to some historical descriptions, does accommodate accelerations as well as accelerating frames of reference. So I now need to go into more details about this. How one person says one thing and other people say something else. So this is the relevant blog by Jonathan Selman, and he says, this summer I had the great pleasure of taking a 6-week course, 5 lectures per week at Cornell, entitled Astro 1106, Relativity, Cosmology and Black Holes, taught by an exceptional professor, Dr. Brazier. For the first part of the course, we focused on understanding the fundamental principles that underlie the theory of special relativity, a field brought to life by the work of Einstein. Every day was eye-opening and extremely interesting. One of the most amazing parts about the course is that in the first 3 intense weeks, I developed the tools necessary to understand the ideas and theories introduced in Einstein's revolutionary 1905 paper on the electrodynamics of moving bodies, and that is Einstein's paper on special relativity. Up until taking this course, I was under the impression that Einstein's work was so incredibly complex that I would never really be able to understand it or to relate to it. In dealing with the twin paradox, he goes on to say, although special relativity does not deal with accelerated motion, so really the problem does not deal entirely with special relativity, and that problem being the twin paradox, acceleration by itself does actually not account for the age difference. And he's talking about the twin paradox still when he's talking about the age difference. So he has been taught that special relativity does not deal with acceleration, and many people get taught that. Now let's look at what Wikipedia says. It says special relativity, contrary to some historical descriptions, does accommodate accelerations as well as accelerating frames of reference. So Wikipedia is disagreeing with what Jonathan was taught, and is instead saying that special relativity can deal with acceleration. An article that explains this situation better is entitled Special Relativity with Acceleration by Gary Helzer. So looking at the article, it says, in the February 1992 issue of this monthly, Rick Norwood remarked that for the circle spinning about its centre sufficiently rapidly, Lorentz Fitzgerald contraction would produce pi, which is mathematical number, the quotient of the circumference by the diameter, to 3. In a letter to the editor in the January 1993 issue, Professor Castellos stated that, on the contrary, the ratio of the circumference to the diameter would increase rather than decrease. The scale used to measure the circumference would shrink. He further observed that Euclidean geometry is not valid in rotating coordinate systems. In the June to July 1993 issue, Norwood attributed the disagreement to an ambiguity. Was a spinning ruler being used to measure a stationary circle, or was a stationary ruler being used to measure a spinning circle? He went on to state that this analysis was an error, since accelerated systems require the general, not the special, theory of relativity. He then posed a question that he could not answer. Suppose a train on a circular track is so long that it fills the track. The caboose is hitched to the locomotive at high speeds. We have a short train filling a long track. What happens? So what he's dealing with is replying to an issue from another person. And he goes on to say, this exchange illustrates the fact that the mathematical tools appropriate to elementary relativity are not as well known in the mathematical community as they should be. In fact, the general theory of relativity is not needed to discuss problems like the ones posed by Norwood. The theory of semi-Riemannian manifolds is needed only in the presence of gravitational masses. Treatments of special relativity avoid accelerations not because they are forbidden, but because the author does not wish to assume calculus as a prerequisite. This is, of course, no barrier in a calculus course. So the relevant bit really being referred to, he's saying treatments of special relativity avoid accelerations not because they are forbidden, but because the author does not wish to assume calculus as a prerequisite. The other things like semi-Riemannian manifolds is all just complications of the mathematics used in general relativity. When what I'm doing here is just looking at the issue of acceleration in special relativity. So repeating what's been said, treatments of special relativity avoid accelerations not because they are forbidden, but because the author does not wish to assume calculus as a prerequisite. So when Jonathan was taught special relativity, it seems that the teacher or teachers did not want to deal with calculus, and they dumbed calculus, special relativity, down for what they were teaching. And they dumbed it down to not dealing with calculus and not dealing with acceleration. And this is an example of moving the goalposts. I've dealt with moving the goalposts in several of my talks, and there are lots of examples of relativity being changed, modified or added to, which is moving the goalposts. In this example, special relativity was dumbed down for Jonathan at an elementary introduction level, and later in the education system a student gets taught something different. So the steps are: introduction level to special relativity, don't deal with calculus. Pretend special relativity doesn't deal with acceleration, and when you go to a higher level of teaching to the student on special relativity, you will then introduce calculus, and you revise things, i.e. move the goalposts, and say special relativity does deal with acceleration. There are lots of ways this could be corrected, such as at an elementary level, don't misinform students about special relativity. However, what has been illustrated here is one of the reasons for moving goalposts, and that is to dumb the subject down to students, and that results in misinforming them. That's the end of the talk here. So basically I'm pointing out Special relativity, when it's taught to students, is often dumbed down, and that is misinforming them. They're coming away with a dumbed down version of special relativity, and so they're believing things about special relativity which is really wrong. And when you want to correct those mistakes from the teaching, well, that's moving the goalpost. You've taught them something wrong, and then you want to teach them at a higher level. Oh, what we taught you earlier was dumbed down, it was not true, and that's moving goalposts. Thank you.